Hi, so this is a video about the lab number 4.5. If we can go to the website, I'm going to show you how you get this example set. Sorry about that. So you get it here, 4.5, you get a zip file, then you can take this zip file and expand it. You get a folder here, and that's what I'm going to show you here. So these are four related examples, very similar examples, but showing you in some kind of incremental manner how you can deal with multiple inheritance using the same example. So if you take this one here, so you see that this is representing, this program is represented by this graph here, this inheritance graph. So you have the TA, which inherits from both student and instructor. The student has a list of registered courses, whereas the instructor has a list of courses, which is his or her course load. And each of the student has a name. A student and instructor has both a name, and the student and instructor has both address. So you see that it's creating some duplication as well as ambiguity here. So to see what's really happening here is that when you create an object of type TA, such as in the code here, you're in fact creating an object, yes, of type TA that has two different parts. It has a student part as well as an instructor part. So that's why the student part has name, it's memory space reserved for where you would store the name. And the instructor part of the TA also has a place where you would store the name that is associated with this instructor part of the object. So that's what is creating this ambiguity here. But you can still, this is not a fatal flaw, you can actually refer by name to each of the specific name of either the student name or the instructor name. So you see that in the code here, we actually refer to the instructor's name. So here you would actually put Joey inside here in this memory cell. This one would still be empty. So I'm gonna stop here and prepare my board for the next example. So here's the second example or follow-up example, which is basically showing the same, kind of the same idea. You have the TA that inherits from a student and instructor, but then what I did is I factorized out the person part of the student and instructor, so I create a new class named person. And then I factored out the name and address, which was the problematic aspect of the previous design. So I might think I have solved the problem here. So in fact, there is a student that is a person, instructor is also a person. Now, why did I put these two persons here separately? Because this is actually what's happening in C++. So if you see what are the different parts of my TA object, the TA object is still composed of a student part and its instructor part. But as we saw before, when there's inheritance between a class and another class, that makes the objects of this kind having a part of this kind. So for example, the student part has a person part. The same thing actually happens with my instructor, whereas the instructor has also a person part. So you see that there are still two different parts which are containing the name and address. So still I would have this problem that if I want to refer to the name, I would have to actually refer to instructor name in order to resolve the ambiguity. Okay, so apparently this is solving the problem, but it is not. If you want to actually solve this problem and having only one person part, then you would have to use what is called virtual inheritance, which I'm gonna explain in the follow-up examples. So this is the third example, just to make sure that people understand here. The first thing I explained, the first example I've shown, is this one here. Then the second one I've just explained is this one here, whereas the third one I'm explaining is this one here. Okay, this is all in the multiple inheritance folder of this lab number 4.5. So if we go to this particular example here, we bring it up here, then what we see is that what I've done is actually, in order to have only one person part to my TA object, I have to use what is called virtual inheritance. So what I need to do here is to say that the instructor and the student, yes, inherit from person, but inherit virtually from person. Now, what does that mean uh, in reality is that, or in terms of the graph here, is that the TAS is composed of a student and an instructor. TA is still composed of student and instructor. But if you go in instructor and student, they yes inherit from person, but they inherit virtually. Now, what that means is that that's what I mean by putting a V here. Anytime that you have virtual inheritance across different siblings in a tree, what happens is that all the siblings that would virtually inherit from the same class are actually sharing a single part of that kind. Okay, so in this case, that means if I have student virtually inherits from person, whereas instructor virtually inherits from person, both student and instructor actually share a common person. So that's what happens. That would happen here as you reserve memory for a TA object with this design here. So you would have the TA has a student part still and an instructor part still, which contains the registered courses, the employee ID, and the course load list of courses, and the instructor ID for the instructor part. But then instead of the student be composed of a person part and the instructor itself also be containing a person part, now this is actually that this whole TA object has a single person part. So in reality, or you know, theoretically speaking, what's happening here, well, the question is to which object does this part belong? The answer to this question, if you draw the graph, it actually, this common part here belongs to the first class that you will find as you go down in the graph here. The first class that you will find in this graph that is inheriting from all of those that virtually inherit this common class. So here, these two here both inherit this common class. If you go down the graph, then the first class you will encounter down in this graph that is inheriting from both of these is the one to which this common part belongs. So that's why the person part actually belongs to the TA part or object. I will stop here and go into the other examples about virtual inheritance. I'm going to prepare my board and then come back. Okay, so let's continue on this lab description. One of the things I just realized I didn't say here is that even though you have made this person here be a common part, there's still some ambiguity because there's still two different paths. You see, it creates some kind of diamond inside of in your graph. So the way that the compiler and the runtime system is going to refer to the elements that are actually inherited is that it would try to go up the graph. If you're trying to refer to some elements down in the graph locally, then it's going to try to find them here. If it doesn't find them here, it's going to try to find them upwards in the graph. Now, by going upwards in the graph, it actually goes to different branches. Of course, some of these branches in the case of virtual inheritance branch back, but that does not escape the fact that, you know, the different paths have to be traversed in order to come back to the common parts. So that's why even though you have somehow resolve this ambiguity for name, that can still be a possibility that you want to refer to either of name that is going through the different paths. So you can actually refer to name as ta.name, but you can also refer to that to a name by referring to the different paths by which you come to the same name. Okay, so that being said, let's go to the next examples. First one is this one here, virtual inheritance 1, which is actually, if I can show you the slides here, that's the example I've shown here. So that's what I've written on my board here. I have exactly the same graph here. So you have the class D inherits from B and C, and then both B and C inherit from A, and then A inherits from A1. So you see that it's creating this, this diamond here, okay? So in this first example here, there's no virtual inheritance. So it's really that these two things here are parallel, as in the first example I've shown about the TA, okay? So in fact, you have two different A's and two different A1s, just like I've shown here. So when you create an object of type D, that object of type D is composed of a B part and a C part. The B part is composed of an A part and an A1 part. P part is composed of an A, which is itself composed of an A1. Then the C part of D is also composed of an A that is itself composed of an A1. Okay, so that's what is this example here. Now, if you want to make it like this, you have to add virtual inheritance. So you need to add virtual inheritance. In my example here, I want only to have this one to be shared, okay? So that's why I'm gonna add the virtual inheritance only here, okay? Now that comes the question as to which of, so example, if I'm creating an object of type D, then this object of type D eventually has two different parts, which are both of these different parts having a virtually inherited A1. Okay, so in this case, it's going to be the D that is actually at the bottom of this graph. Okay, if I would be creating a C, then there would not be such an ambiguity, and that would be just basically a normal inheritance graph. So that's what this example here is showing. So I'm going to reset my board to continue the example. So here you see what's the result here of adding the virtual inheritance here. So I repeat, what this means is that this class A1 is virtually inherited from A. So that means if ever you have some other classes that many of them are inheriting from an A, then the A1 part of this A is going to be shared among these different parts of the object you want to be creating. So here, when I add B inherits from A, C inherits from A, and D inherits from B and C, then basically that means that D has only one A1 part. So that's what I'm showing here. I can stop the sharing here to make it more clear. So that's what I'm showing here. When you have this inheritance graph with the virtual inheritance here, then that means that the D is composed of B and C part. D is composed of B and C part, and B has an A part, C has an A part, B has an A part, and C has an A part. However, these both of the A parts of B and C are sharing a common A1. So now the question becomes to which object or part does this A1 belong? Okay, the answer is, as I said before, if you have an inheritance graph that uses this down the line, this virtual inheritance, then this part here, this common part, belongs to the class that you encounter first as you go down the graph. The first class that you encounter that actually somehow contain all of the parts that you want to share. So namely, in this case, it is the D class that is the first down in the inheritance graph that actually contains both of the A1 part of C and the A1 part of B. So that's why this A1 belongs to the class D, or the objects of class D. So that's why when you create an object of type D, it has a B part, a C part, and a common A1 part. Okay, so that's how this is happening. So this is the last example. So if you go and look at the slides for the last example, which I'm going to show you here. Here we go. So that's the last example. Now this is showing here the graph when you have the virtual inheritance. Okay, this is when you see that it comes back to a common V here. It already shows that this is how it should be using virtual inheritance. However, if I can show what it is, without having the diamonds here, then actually E inherits from C and D, and then C inherits from A and B, and then all of A, B, and D inherit from V. So that's why in this view here of this graph, if you create an object of type E here, then the E has a C and D part. And then the C has an A and B part. And then the D has a V part. And both the A and the B have their own V part. So you see that here, if you look at the E itself, it actually has 3 separate V parts. Now in this graph that I'm showing on the slide, what I'm saying is that what I would like to have is that all of A, B, and D would share a common V part. So what I have to do then, when I say that A inherits from V, and B inherits from V, and D inherits from V, I will say that A virtually inherits from V, B virtually inherits from V, and D virtually inherits from V. So I'm going to change the board and come right back. Now, if I make my all my A, B, and D to virtually inherit from V, then essentially what I'm saying is that all the A, B, and D share the same V. Okay. Now this has 2 possible, of course, here you see that there's 2 different diamonds here. That's with this diamond that is embedded in this bigger diamond. That's why I'm showing this, this example here. Now, you have to understand this kind of design does not happen very often, of course, but I'm just showing you this particular example to exemplify what does that mean and how does it work. So if I'm creating an object of type E, that actually means that there's a C part and a D part. So the E has a C part and a D part. And the C part has an A part and a B part. The C part has an A part and C has an A part and a B part. And then there's the D part. Sorry about that. So there's the D part. Yes, okay. So E, sorry, E has a C part as well as a D part. I'm going to come back to that later. And then the C part of the E has an A part and a B part. Now, comes back to the same idea here. If I'm creating an E, then the E here is the one that shares all the instances of, or not instances, but the V parts of A, B, and D. So if I'm creating an E, then all of A, B, and D, if I'm creating an E, all of A, B, and D share a common V at the level of the E part. So that's why the E actually has, or the part V, the common part V actually somehow belongs to the E, which is the first one in the hierarchy that somehow refers to all the three different common V's. Now, then for this design, there's actually two diamonds. So that actually, I could actually also create a C. So what's going to happen if I create a C? If I create a C, then I'm going to have an object of type C that is stored here. Now, what is this object composed of? It's composed of an A and a B. I'm going to leave some room here because, of course, we're going to see that there's a common V. So the C has a part A and a part B, a part A and a part B. And then both of these A and B share a common part V. The point is that then the question is to which object is this part a part of? The answer to this question is in the graph, as I'm creating a C, the first class I see down in the graph in this sub-inheritance graph here, first class that contains both, that refers to both of these parts is the class C. So actually, in this case, the part V belongs to the object C. So C is composed of an A and of a B, and also of the common part V that's supposed to belong to both A and B. So this is, if we go to the final slide of this example on the lecture material, this is how you actually do it. And I'll come back to the parts later in this explanation. So I have here to add the fact that A virtually inherits from V, B virtually inherits from V, and D also virtually inherits from V, if I want to achieve what I was describing before. Now, then, if you look carefully, you see that in this original code here, A actually calls the constructor of V. So that's why I'm including here another constructor that does not use the default constructor. So it explicitly calls a base class constructor. So for example, the constructor of A is actually calling the constructor of V. So when I call this constructor of A, it explicitly calls this constructor of V here. Now, as I just explained here, the point is that somehow the V, as you put virtual here, somehow the V is not a part of A anymore. It's actually a part of what is down in the graph. Okay. So if you're creating a C, then the A part should not be calling a constructor to construct its own V part, okay? Because there's not anymore a V part of A. It's now a V part of C or a V part of E, depending on if you create a C or an E. So if I'm creating a C, as we see here, there's an A part of the C and there's a B part of the C. So as this object C is being created, it doesn't make sense for A to actually call its superclass, its base class constructor. So it should actually be C who will be calling the base class constructor for the class V. So that's why in this design, you have to add this call to the base class constructor of V, even though you see that V is not inherited from C, but because you made this virtual inheritance here up in the chain here, then you make it so that something should be calling here the constructor of the superclass, and it cannot be either A or B. So it must be C if you're creating an object of type C. Now, the same thing happens for E here. So as this E object is created, then constructor of this is called, and constructor of this is called. And then supposedly here, this one should be calling its own constructor, and this one too, which would create three different copies of this of this V. Now, because I've added virtual here, actually what's going to happen is that if I'm creating an E, then the explicit call to V here in my class A and my class B and my class D are going to be disregarded by the runtime system. There's even some compilers that would make it tell you that it's not valid. Okay, so if you create an E, then there's one V part. So it should actually be E that's going to be calling this base class constructor of V. So that's why you add it here. Note that if you would not have virtual inheritance, E should not be allowed to call the base class constructor of a class that it is not itself directly inheriting. Okay, so that's because you have virtual here upward in the tree that E is now allowed to call a constructor that is, let's say, transitively inherited. So that's it for this video.